super excited to welcome you guys to this session all about interoperability. So as you guys know, Avalanche is a multi-chain network. So interoperability is really at the heart of this network, and it allows these different L1s that we have in our network to interact with each other with a primary network. So super excited about this session. We're going to kick it off with a panel with some people from Avalanche, but also our ecosystem to talk about how the interoperability works and what they're specifically building. And then you will hear some members of the DevRel team dive deeper into, like really how the interoperability works under the hood, the technical parts of it, and you will also see how to set interoperability features up on your L1 with another member of the DevRel team. And then the panelists that you will see in a minute will dive deeper into their specific sections. You will hear something about improvements coming to the interoperability protocols, but also how bridges enable your L1 to bootstrap liquidity, and then also, like more advanced applications. So super excited to welcome the panelists. First of all, Michael from the Avalanche team, and then also Chris and Angus from Tesseract and XKOVA. Awesome. Hey everyone. Thank you for making it out here. And so first of all, why don't you each introduce yourself? Michael, maybe you want to start.
Sure. My name's Michael Kaplan. I'm an engineering manager at Avalanche on the platform engineering team. Previously worked on the Avalanche bridges, and then became more focused on more general interoperability and interchain messaging. So yeah, very excited to be here today to talk about all of that.
Awesome. Chris.
Hi, my name is Chris Fusillo. Co-founder of XKOVA, which is consumer infrastructure for blockchains, protocols, and stablecoins. Also co-founder of Bitcoin L1, which is a big fan of ICM. We're going to talk a little bit about that today. Appreciate you all coming and hanging out. Excited to be here today.
Awesome.
And my name's Angus. I'm a core contributor working on analytics for Tesseract and YieldYak. I've got a background working in iGaming, and I've been in the crypto space for about 4 years now.
Awesome. Thank you very much for coming all out here and taking the time today. So, Michael, why don't we start? And first, maybe you can give us like a high-level overview, like why does the Avalanche network need interoperability? What core problem is it solving?
Sure, absolutely. So I think everyone here is aware that Avalanche is a network of many networks, and we have a multitude of L1 chains all launched for their own specific application purpose. And because of the fact that they are on their own network, they need to be able to leverage utilities that exist on other chains, particularly the C chain, where all of the liquidity tends to start off on Avalanche. And when you are launching your L1, it's actually a big, or previously was a big barrier to entry to have some messaging provider support your new chain because they need to run a node or otherwise be able to connect. And paying for those integrations could be very cost prohibitive for these new projects. And really from the beginning, we wanted to set out to build a protocol that would be natively interoperable in that when you launch your new chain, you are able to seamlessly connect with any other chain in Avalanche out of the box with no trusted third parties and without needing to go and ask anyone to integrate with your new chain. You can do it all yourself. And that's really kind of the framework that we set out to build with ICM. And I think over the past 6 months or so, I've really seen its usage pick up on mainnet, which we've been super excited to see and gotten a lot of great feedback from.
Amazing. So Andrea will talk in a little bit on exactly how that works. Maybe you can give like a very, very high-level overview. So does it of the architecture? Does it involve any trusted third parties? Does it involve any wardens for the bridge or anything? Is there anything like that, or like how does it actually work?
Yeah, so like I mentioned, no trusted third parties at all. It's really just the two validator sets of the sending chain and receiving chain that are involved in a given message. It uses BLF's aggregate signatures from the source chain to actually prove that an event occurred. And then when you process that message on the destination chain, the key trick is that you need to know of the validator set of the source chain in order to be able to look up the identities of its validators and their public keys and then verify that aggregate signature from their current validator set. And this architecture only works because of the Avalanche P-chain and how it acts as a validator set registry for all of the Avalanche network. I think a big challenge of sending messages from, say, Avalanche to Ethereum or Avalanche to Solana or Avalanche to any other chain is that the validator sets don't know of each other's existence. But because all Avalanche L1s register their validator sets on the P chain, we can enable this type of interoperability primitive.
Amazing. So Chris, you've set up a bridge on your L1 that actually leverages the interoperability protocol, but is kind of like this application layer on top of it. So we'd love to learn like how was your experience, and what would you tell any builder that wants to, like not only connect to the rest of the Avalanche network, but also bridge assets through the interoperability protocol?
Sure. So my first foray into it was with Bounty 9000, which was a great program that Avalanche and the Team 1 DAO put out. I highly recommend you participate in these because they challenge you to build in an environment where you might be able to win some prizes and also learn a little bit. So that was like my training, essentially getting into it was starting with that. I'm happy to say they won first place in Bounty 9000. But the thing is as a developer, you need to participate in these things because they are super important for helping you hone your skills, right? The second thing is definitely study up on AWM Relayer. Relayer is something that's a piece of software that runs in itself. It relays messages from chain to chain. Understand how that works intimately, and don't assume it's just contract deployments, right? You need to really understand how that works and what the mechanisms are there. And the third thing is join the Telegram chats. The DevRel team is there 24/7. They're there to help you do whatever you need. You can ask any question. There's even Hal, an AI in there. He's very conversational. He does a great job of explaining things if you have questions. Definitely work with the guys on the Telegram chats if you have any questions.
Amazing. So in your talk, you're going to dive a little bit into how that application layer could look like, right? Like building on top of it. So can you just give like a very high-level overview of how asset bridging is kind of like separate from like the interoperability that is below it?
Yeah, so we want our users to be able to bridge tokens from C chain over to L1 without even knowing that they're bridging. So from an application layer, like you have to build out the user experience to make it seamless. So people can just if they need to top up their tokens, they just click top up, and then the tokens come from one chain and go to the next, and everything's on the back end. So it's all in the user experience.
Yeah, amazing. So Angus, I'd love to learn like. You and the Tesseract team have built something that is building even a level on top of that, right? Like, so we have the interoperability layer that Michael and his team have built. Then we have the token bridging layer that also Michael and his team have built that abstracts all that away. And then you guys build something on top of that that is not only moving the tokens from one chain to another, but also swapping these, I believe, on a DEX. So I would love to learn a little bit on like how that experience was and what were kind of like also the challenges, the UX challenges you and your team have overcome?
Yeah, so the first thing I'd say is that like the use case for this is that developers that are creating their own L1 through the use of ICM and ICTT, interchain token transfer, they can access liquidity on C chain without having to deploy a DEX on their own chain. This means they can swap tokens seamlessly through Tesseract from their L1 to C chain, swap it for something else where the liquidity is actually deployed, and then swap it back all just with a single transaction. Some of the challenges we face, and Tesseract does this kind of arbitrarily many times, finding the best path across any number of L1s for which there are links between them. Some of the challenges were, on the back end, it was kind of creating a data structure such that this fits in, well, a data structure which is decoded and encoded. That's the payload of the send and call for the ICTT contract. So you need a good data structure with like an array of hops that can then be decoded, encoded, sent with the message, and then on the recipient chain, decoded and then passed, and basically then you carry on doing things, and you have this sequence of hops, we're calling them, in an instruction struct. So that's kind of the most challenging part of the back end. And then on the front end, as the number of L1s being deployed increases, it's like huge scale. So the pathfinding optimization and querying of routes becomes quite difficult. And also keeping track of all of the different transactions that are linked across many chains. So we have the message ID is emitted in an event with the ICM from teleport to messenger. So if you're sending from one chain to another, the send message and the receive message both emit the same message ID, so you can link them and you say, okay, these are related transactions. Because Tesseract is kind of doing a step further, where it can go from one chain to another, to another, to another, the message IDs for the first 2 transactions will be the same, but then the second 2, it will be a different message ID and so on. So one challenge was kind of how to piece all of this information together, and we ended up creating our own unique Tesseract ID, which is kind of made in the first call to our contracts in a similar way to the message ID for Teleport and Messenger, but that is persistent across all of the transactions for a particular action on Tesseract, and helps with the tracking. So yeah, keeping track of everything and updating the status and the data structure for the backend were the big challenges.
I see. I think you mentioned something very important, right? Like you said, the user is issuing a single transaction wherever they are, and without them really noticing or doing anything, like this transaction triggers a message being sent, tokens being bridged to a different chain they are not necessarily even aware of, and then a swap is done there, maybe for reasons of liquidity or anything there. So that's a very interesting thing. I believe you guys enabled it when you were building ICTT. You built in just not the base functionality of transferring tokens, but also this additional feature of, I believe you call it send and call, right? So maybe you can touch a little bit on what that exactly means, what doors it opens beyond, like DEX swaps, and what were kind of like the considerations when you guys have built this?
Yeah, well, I guess to start off, just want to say how excited we were about both of the projects using ICM, both BTCL1 and Tesseract. Like when we first learned about them, we're like, this is exactly what we have been hoping for years, so thank you both. But as far as send and call is concerned, yeah, we envisioned L1s launching and being able to seamlessly move liquidity from the C chain onto their chain without any trusted parties, as I mentioned. But as soon as we had that, we asked ourselves the question, okay, how is that liquidity actually going to be used on that chain on the other side of this transfer? And that's quickly became apparent that it would need to be programmable in some way. So if you are a user and you have, say, BTC on the C chain, or BTC.B on the C chain, and you want to move it to an L1, that's great. But then if you want to put it to work on the L1, then you need the native token of that L1 to send a transaction on that chain and take whatever action and put your assets to work how you would like to on the L1. And being able to automate that into a whole flow into a single user action on one chain was really what we set out to do with send and call. I think other interoperability protocols refer to it as intents, because you're not just bridging tokens, but you state what your intent is for those tokens on the destination chain. We called it send and call because you're sending the tokens and then you're calling contracts and executing arbitrary logic on the other side with them. So yeah, we are super excited to see how far Tesseract has got with that. I think there's a lot of really cool use cases out there to be explored.
Amazing. Yeah, if any of you guys can think of any use case that is kind of like beyond, like we've heard, right, like the interoperability protocols allows for arbitrary messaging, ICTT allows for token bridging, and also, like calling arbitrary contract logic. So it's like, just like for the group, are there any other use cases that you guys are incredibly excited about that go maybe beyond just token swaps, but basically unlocking more of, like either DeFi opportunities or any other things that are, like enabled by interoperability and enabled by the token bridging, but then you can, like formulate these intents, call these contracts. Is there anything you guys can think of?
Oh yeah, so with XKOVA, we're enabling our users on individual L1s to deposit USDC into single-sided staking contracts like through YieldYak and Avant on C-Chain. So we're using ICM to allow them to do that. So in BTCL1, if you log into Satly, which is the consumer front end for BTCL1, you'll see a little login that says coming soon, stake your BTC, earn yield with Avant. So we'll be using ICM in order to make that happen, which is a pretty cool thing.
Yeah, mine's kind of similar, I guess, but I would think of say like a gaming-related L1 where players probably only ever interact with that they might not even be aware of what an RPC is or to change to interact with some other chain, and you want to offer them the ability to like earn yield on some of their idle assets. Our smart contract dev, Simon, actually got a proof of concept of this working already, where you could bridge from an L1 to C chain and deposit into like a lending protocol, for example, to earn yield, all from the L1. So yeah, there's a big opportunity for like idle assets on isolated, say, gaming L1s to earn yield as well through a single transaction from their perspective.
Amazing. So, Michael, remind me, when did we launch interoperability on mainnet? And maybe you can touch a little bit on how the adoption has been going, especially recently.
Yeah, I actually have a graph kind of showing this in my presentation that's coming up later. But so ICM launched in the EVM on mainnet last March 2024. And from March until, I believe, August or September, we actually didn't see any mainnet usage, which in retrospect was probably to be expected because we needed to give people time to kind of parse through what it all meant, think about what they could build using it, and then figure out how to build it. And to all of your credit, that has happened since then. Really starting in September and October, we started to see a few projects use ICM on mainnet, and that has picked up parabolically since we were last together in Buenos Aires. So I believe in April there was 15 or 16 chains on mainnet actively using ICM, and just last week actually we had the first day where there was over 10,000 messages sent in a single day.
Yeah, that's amazing. I believe that was MapleStory, wasn't it?
Due to there's a big bump when launched, for sure.
A big bump. Yeah, there was definitely a spike. So super exciting. We see that interoperability is really at the core of the Avalanche network. So I'm super excited to touch with each of you later this day into the specific sections, have you all deep dive into it. Thank you very much for joining me on the panel today. And yeah, we will see you all in a little bit. Thank you.
Thank you.
Thank you.